Okay, so I want to record another video here because I want to show you how I read image files and how I modify them and get them onto Facebook. It's a very interesting process. Okay, so what I'll do is I'll switch to my display and show you my code. So I still have some files open from before. Now here's the thing is I am going to switch to my image read test, and it's easy to do that because alright, so okay, now this is very interesting. Well, what I'll do is I'll run the code as is. I'll change all I have to do is change the word write to read. Whenever I want to change between which function runs, I just change what it calls in the main function. Okay, so now I'm going to run my code again. First, let's just clear what it has there, and let's see what it does. Now, this is interesting. Failed to read file in.bpm doesn't exist. Pointer is null. Yes, that's right, the pointer is null. Oh, and I forgot to delete these things. So yeah, see, the pointer is null, and so it doesn't do anything, and it's good to show you the error. Because the file in.bpm doesn't exist. Now that was a different thing that I had been doing. But what I'm going to show you instead is I'm going to show you I have some input files here. Now I have several different files here. I have some JPEG files. There's my face, and notice I have the JPEG, I have the PPM. See, I have different formats, and there's another one from my Love Nikki game on the phone. I love that game. And then there's Princess Rosalina, my favorite Nintendo princess. And this new one, Star Ruin. Yeah, so the Star Ruin one is a very interesting one. I love this picture because it's so colorful, but I'm going to show you the kinds of things I can do with this image. Now, I've done amazing things with the other images as well, but I'm going to show you the process of how I will load this image into my program. Now, when you open up a JPEG, it displays on my image viewer because it's a standard image format. However, what I need to do is I need to get it to open with my hex editor so you can see how it works, because I definitely want to show you something. Let's see. Let's look for my hex editor here. So there is, I'm going to open this in hex editor. Notice this looks like complete gibberish. Now, all of these things mean things, I'm sure. However, it's not a format that I understand. It's probably heavily compressed, as JPEGs are always compressed. Oh. I think Larry's texting me to letting me know whether he can pick me up for work or not. So I will not check that right now because I'm busy with the programming video. But I have it set to play What is Love, Baby, Don't Hurt Me. Yeah, okay, yeah. Because that's like one of my all-time favorite songs. Hopefully that will shut up. Okay. So, okay, finally it's quiet. But in order to actually load this image, there's something I have to do. So first of all, I'm going to change into the... Wait, I changed into the wrong directory. I need to change to the I directory. So what I have to do is I have to turn it into a PPM file, and you will see why soon. So now if I do magick convert, let's see, starruin.jpg to starruin .ppm. Let's see what it does. Okay, yeah. Now, of course, I did not capitalize the name of the JPEG, yet it still produced a file. So let's see what it produced. Let's open this in the image viewer. Yes, see? That's a portable pixel map file, and it looks identical. I choose that portable pixel format for my image loading. And that is how I get images loaded in my program. Now, and you will see how I do it. I'm going to show, that's the purpose of this video, is to show you how I... He's still texting me. Oh man, I should have not done this with my phone on. Okay. He'll have to wait. Okay. I guess I get interrupted one way or another. Okay, so let's open the... Okay, so what you see here is the width and the height of the image is encoded. The portable pixel format is related to the portable bitmap format, but it contains full red, green, blue color. What you see here is after the initial header containing P6, the header identifier, and then the width, and then the max value, what you see here, these values are all red, green, and blue values. So they're very weird. I'm not even sure why it contains so much seemingly random data, but it's a big file. Yeah, it's very weird, so you never know what it's going to look like. However, it displays. Now, let's try loading that file into my program. So what I'm going to do is I'm going to go back to my source code, and it's going to be loaded from the I format here. Okay, so let's see here. Okay, so it is the star ruin .ppm format. Okay. So it's going to load this image, and we shall see if it loads properly. And what it's going to do is, after it loads that image, it's going to convert it to a 24-bit bitmap file. And so I'm planning to show how this works. So let's try it out and let's see if it runs right. What? No target specified. Oh, that's right. I'm in the wrong directory. I have to change back to the main directory here. Okay. So it opened the PPM file, and then it saved it to a bitmap file. Let's see now if it shows up. Yes. Okay, we have a bitmap file. Let's see what it looks like. Yes, and the image looks identical. Isn't that just beautiful? Yeah, and when you can look at the tiny little pixels here. It's really great. So here's the deal. Yes, we have a very cool looking image here. Now, how does this work? I want to briefly show you how it works because... Okay, to start with, I have a lot of code that you're not going to understand. I have all sorts of functions, memory allocation, writing a checkerboard, and it writes a checkerboard of the image, but it covers over it with the with this, because I'm modifying this constantly. So what it does here is, if it couldn't load it, it will say the pointer is null, and it will exit the function so my computer doesn't crash. And when we're saving it to that bitmap file, and then it frees the memory for that pointer. You have to manage all the memory yourself in the C programming language. But I like it that way because I'm kind of a control freak when it comes to computers. Anyway, enough about me and my computer obsession. I'm going to show you how it actually works. So I need to go back to some of the source files to briefly show you how it's working. So first of all, in the the BBM IO file. See, only I know which file contains what. The BBM IO file here has all these various functions. They all do various things. I wrote them all. They're beautiful, but they need some cleaning up. So, but near the end of this function, I have this is called BBM load. And what it does here, what you'll see is that I pass I pass the address of the pointer and of the width and height variables to the function, and it BBM load. And then here's what it does. I have some code here that will free the pointer if it is already allocated to something. And then what it does is it tries to identify the type of file using some very complex math here. Using a character pointer, and at first it finds where the dot is. And then it will, based on what the extension that it finds here, it tells what it is. For example, if depending on these different formats, I have functions that load my own formats. These first three formats are my own formats that I invented. There's a lot of construction work there. And then the PBM, PGM, and PPM formats, which are actual formats that were used in the 1980s. They're not used much anymore today, but they're very easy to read. Now, so the portable pixel map one is the one that's important. So how does it work? Well, there are two more header files that I need to open because I have a lot of code. So this one will open, and first let's look at the function that loads the PPM. There's that one saves a PPM, but let's look at this one that loads a PPM file. Now, it's complicated. It's a very big function, but what it's doing is passes the pointer to all those variables there, and it reads the data, sees if the header is correct, and then it scans the text for the width and height, and then it scans the max value. It doesn't use the max value. It assumes it is 255, as it usually is. And obviously it works correctly. And then basically what it does is the color values are stored in red, green, and blue pixels. 1 byte for red, green, and blue, and they're in that order. So it gets those variables for red, green, and blue, and then what it does is it constructs them into a 32-bit integer. It does some bit shifts and turns them into the format that my program understands, and then it saves that particular pixel into the into the array of pixels. So that's what it does. I know it looks horrible. You have to have years of experience in the C programming language to understand pointers to pointers and addresses of variables and crazy stuff. So obviously I'm pretty experienced with the C programming language, but it's a hard language, and C++ is even worse as far as trying to learn a language. Okay, but then, so we see how it's loaded the PPM file here, but how is it saving to the bitmap file? Well, I'm going to show you that next. Now, for the bitmap files, there's a complicated header. There's a header that contains much data, and I actually have several ones. I have a function that saves to black and white bitmaps. I have one that saves to 16 shades of gray, and then I have another one that saves to 8 bits per pixel gray images, and then the one that I just used was the save BMP red RGB. It saves to 24-bit red, green, and blue. And this is a very complicated function because it has to write the header. It keeps track of where the pixels start, and then it writes all of these different variables here. It does all this stuff with the magical colors and stuff, and it writes every single byte, and it even adds padding to the end of the rows because they have to be a multiple of 4. So, I mean, we're talking hours upon hours of reading about image formats. Specifically, the Windows bitmap file format was one that I spent a lot of time on because it's such a widely used and popular format. Now, notice this function. This is the actual function we called in the code. Now, we saved it as a 24-bit BMP file, and we got the result that I wanted in this case that looks identical to the original image. So it's a 24-bit bitmap file, and it's over 2 megabytes. However, we can change which type of image it is. So look at this. For values 1, 4, 8, and 24, it calls different functions. So let's test out the 8-bit grayscale. So what I'm going to do is let's change the number 24 to 8. And then when I run the code again, it's going to write a new image file, and now it's grayscale. Isn't that beautiful? I just converted the image into grayscale that way, and it's super cool that I did that, actually. In fact, what I'm going to do is I'm going to upload these to Facebook as I go along. I'm still uploading the previous video here, but it should let me upload the images to Facebook. So what I'm going to do is I'm going to upload my images here to, okay, so I need to go to the O folder. So I'm going to upload this bitmap file. I'm not going to upload the 24-bit one because I already uploaded that one to Facebook, and then I downloaded it. So there, first I'm uploading. It's weird. It did not work. Sometimes I have to click into here and then I have to load it. Okay, so first I'm uploading that bitmap file that's 8 bits to Facebook. It takes a while because I'm already uploading the video and it uses up my bandwidth. So there it is though. So it should have, yeah, so it loaded up the grayscale version of that image, which was originally full color. But then I'm going to change the bits per pixel to 4. There is such a thing as 2 bits per pixel, but the Windows bitmap format doesn't support it, so I don't have a function for it. Plus, I haven't had all that much programming time anyway. But let's see what it looks like with only 4 bits per pixel grayscale. It looks pretty much the same, doesn't it? But it has only 16 shades of gray. You can see at the bottom it looks a little more pixelated here, but yeah, it still looks cool. So I'm gonna also upload that version, which is slightly different. Most people just at a glance won't be able to tell the difference between 4 and 8-bit grayscale. And the whole reason for doing grayscale, besides how it looks cool, is that you also save space. If an image can be expressed as grayscale, then you don't have to have it be larger by having full red, green, and blue spectrum. So there's another one. But now I'm going to try something. If I change it to 1, we should get an image that's only black and white. So this will be my final test for this video, and let's see. I have no idea what this is going to look like. Okay, let's see here. Let's view this. And whoa, does that look freaky. It doesn't look very much like the original image, but it sure is cool. That's what it looks like when my program automatically converts to black and white. There's a very simple formula. In fact, I'll show you very quickly how it's doing that. Let's go to my black and white thing. So it does cast black white. That's what BW stands for, cast black white. I actually have a function that I wrote that's in this file over here that it's calling. And what it does, it's very cool. It takes the red, green, and blue values from the pixel, puts them in separate variables. It adds red, green, plus blue together, then divides them by 3, and then it right shifts it by 7. So you will get either 0 or a 1, and that will be basically how it works. Is it's used as an index. So it creates a bit and then it indexes. Let's let's see here. I'm trying to remember how this works here. Oh yeah, because basically uses that bit as an index into the color map, because there's actually a color palette for Windows bitmap files. So it's black and white in this case, but it could be other colors. But it casts it to be either 0, 1, 0 representing black, 1 representing white. So that's basically how we end up getting that cool. What? That stupid person keeps messaging me, and I don't know him, and I don't care right now. I hate interruptions, but I did get on Facebook so I could upload these image files while I still have them here before I forget, because they do look amazing. So anyway, that's the final image to upload for today. I hope you've enjoyed this video. I've basically shown you the process, how I use ImageMagick to convert a JPEG into a PPM file, and then I have other functions to turn it into other formats. The BMP format is the one I've spent the most time on. So you just saw me load an image and then convert it into several different formats. So anyway, yeah, that should be all for this video. Now I have to see what Larry says, and I need to get ready for work, which takes up a lot of my time. So anyway, this has been another programming video by Chastity White Rose. And so we shall see what becomes of my programming project, but it's getting good. I can write checkerboard image files, I can load and convert images to other formats. It's all a matter of time. And by the way, ImageMagick, you know, the tool magick that I use to convert from JPEG to PPM, I use that. That is a command line tool for converting between image formats, and it's a very powerful tool. In fact, some of my code doesn't even work without that program installed. So I'm relying heavily on already existing code. However, the code that's writing these image formats, like the bitmap file, that's all my own code based on my own understanding of the format. And I simply use the image conversion tool, ImageMagick, in order to convert things into a format that my program knows how to read. Because I can read PPM files because they're so simple. They're the easiest format to read, actually. Even easier than PBM itself, which I can read PBM and PGM as well. Anyway, enough ranting. That's the end of this video, but as you see, I can do some amazing things with my computer programming. I'm a graphics programmer now, and I'm very happy about that.